Okay, we are going to look at your study guide, and I'll explain how to do each one of these problems. The first question asks you which of the following numbers are divisible by 5. You need to study all of your divisibility rules that are in your ISN because tomorrow's test, it may not be 5, it could be a different number. The rule for 5, though, is to look in the ones place, and if it has a 5 or a 0, then that number is divisible by 5. So 125, 10, and 410 would be the only numbers that 5 would go into without a remainder. Keep in mind, if you get stuck on the test and you don't know what to do, you can always just divide that number into all of them. It'll take you a little bit longer, but you would get the right answer if you divided correctly. Excuse me. Use the divisibility test to decide which of the numbers are factors of 627. If it's even, 2 will go into it. Well, 7, in which you look in the ones place, 7 is not even, so 2 is out. For 3 and 9, if the sum of the digits is divisible by 3 or 9, then that number, the whole number, is divisible by 3 or 9. So we add up the digits. 6, 7, 8. 8 plus 7 is 15. Does 3 go into 15? Yes. So 3 will also go into 627. Does 9 go into 15 evenly? No. So 9 is out. The rule for 4, if the last 2 digits are divisible by 4, then the number is divisible by 4. But 4 doesn't go into 27 evenly, so 4 is out. The last digit is 7, so 5 and 10 are out. So the only answer was 3. Number 3, same kind of question. This time it's multiple choice, so that should help you narrow things down a little bit. But I know it doesn't go into, 10 doesn't go into it because the last digit is 6, so it can't be A, and it can't be B because they both have 10 on them, and it can't be D because the ones place is a 6 and not a 5 or 0, which is the rule for 5. So just to be on the safe side, go back and check and see what's left, and does it go into it? Yes, 6 is even, so C is the only option. 2 is the only number that goes into that evenly. The next section was dividing either by a whole number or decimals. So first, the rule when dividing by a whole number into a decimal, you simply bring the decimal up and divide like normal. 8 does not go into 3, so you put a 0, but 8 goes into 32 4 times. And the answer is 4/10. For number 5, bring the decimal up. 2 doesn't go into 0, so we'll put a 0 above that. 2 doesn't go into 1, so you must put a 0 above that as a placeholder. And 2 goes into 16 8 times evenly, and we're done. For 6, 7, and 8, when you're dividing a decimal into a decimal, you have to remember what I think in my head is over, over, up. Over, over, up. So that means you're moving the decimal over, over, then up. So now, because you want the divisor to be a whole number, so now it's 9 into 30.6. Now you bring the decimal up. 9 goes into 30 3 times. Subtract, bring down. 9 goes into 36 4 times. So our answer is 3 4/10. For number 7, you should rewrite it so that this is the divisor. This is the dividend, the one that goes under the bracket. And the 0.07 is the divisor, which goes on the outside. It's a decimal into a decimal, so we've got to move it over, over, up. In other words, we need to make this divisor a whole number, so we're going to move it over twice. If I move it twice in my divisor, I must move it twice in my dividend. Bring it up. 7 goes into 42 6 times. You can put 6.0 or just leave it 6. And number 7, solve the same way. Let me rewrite it over here. The question is 1 8/100 divided by 4/10. So we're going to move it over, over, up. 4 goes into 10 2 times. 4 times 2 is 8. Subtract, bring down. 4 goes into 28 7 times. And our answer is 2.7. And we're going to see that that would be C. The next section is talking about prime and composite numbers and prime factorization. So for number 9, if we're going to write the prime factorization for 4, that's just 2 times 2. You're trying to break up the number, multiply it by something other than 1 until they're all prime. So the answer is just simply 2 times 2, or you could write it 2 squared, either way. Number 10 asks you to write the composite numbers from the list below. Composite meaning it has more than 2 factors. 47. The only number that goes into 47 besides itself is 1. So that's not right. 23 is also prime. The only thing you can multiply to get 23 is 1 times 23. 1 times 17, same situation. 40, I know a lot of things that go into 40, like 2 times 20, 4 times 10, so that is one of them. 42, I know 6 times 7 is 42, so that's composite. 3 and 5 only have 2 factors, 1 in themselves. 18 and 27, 9 goes into both of those, so they will be on the list of composite as well. What is the prime factorization of 16? So we have 4 choices. If I work it out with a factor tree, 4 times 4 is one way that we could do this, and of course then each of those 4s could be broken up into 2 times 2. And we have 4 2's, so the only one that has 4 2's is D, and D is the right answer. Just a hint, also, this is whatever the prime factorization of the number, it needs to, when you multiply it together, it should equal 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. That, I knew that could be a possibility because 4 2's, when you multiply them together, get 16. But here, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is something. It's not 16, so I knew that could be it. And the same thing with both of these. Once you got past that 4th 2, and they're still multiplying it, it's not going to equal 16. So the only choice is D. Use division of primes to find the prime factorization of 27. Get another piece of paper. Okay. So division of primes is the birthday cake method. You start with 27. You first say, 2 is the smallest prime number. Does it go into 27? No. So then ask yourself, the next prime number is 3. Does 3 go into it? Yes, 9 times. Does 3 go into 9? Yes, 3 times. Does 3 go into 3? Yes, 1 time. And you stop when you have a 1, or we look at a candle at the top of the cake. So the prime factorization is going to be anything on the side. 3 times 3 times 3, or 3 cubed. The next question was to do the same thing, but this time you're looking at 99. 2 doesn't go into 99, so once again we're going to use 3. 3 goes into 99 33 times. 3 goes into 33 11 times. And the next prime number that would go into 11 is 11, and it goes one time. So our prime factorization is 3 times 3 times 11. Number 14 is 44. Start with 2. Yes, it goes into it 22 times. 2 goes into 22 11 times. And the only prime number that goes into 11 is 11. And our prime factorization is just 2 times 2 times 11. Again, just to check to see if you have made a mistake or anything, when you multiply these numbers together, it should give you the number that you started with. 3 times 3 is 9, and 9 times 11 is 99. 2 times 2 is 4, and 4 times 11 is 44. So I know more than likely I have those right. Well, I know I do, but on the test, that's what you could be thinking. So the next question, question 15, it's multiple choice. Use division by primes to find the prime factorization of 81. So remember, to eliminate some questions, you could multiply them across and see which ones equal 81. I know this is going to be wrong because it's got a 1. 1 is not prime. So even though 3 times 3 times 3 times 3 equals 81, it has a 1, so that can't be right. I'm going to use a factor tree to solve this one. So that's the prime factorization, and that would be answer D. So please look for that 1. If they have a 1 on it, it cannot be the right answer, even though that does equal 81. Okay, number 16. Again, use a factor tree to find the prime factorization. Think of two numbers that when multiplied together give you 170. Well, I know 17 times 10 will give me 170, so that will work. 17 is prime, so that comes straight down. And I can multiply 2 times 5 to get 10. So my prime factorization, because all those numbers are prime, would be 17 times 2 times 5. Question 17. Which factor trees are correct? Again, tomorrow, I think I told you this in class, this is kind of a trick question because neither one of these are correct, so neither is the answer. Tomorrow's test, there will be an answer, it won't be neither. But 7 times 3 is 21, not 10. They must have added this, so that's not right. And then this one, 3 times 3 times 4, this was almost right, except they should have broken that up into 2's. So because they didn't, that's not right either. The next two questions are multiplying decimals. We'll work 18 out down here. 66 hundredths times 6 tenths. You're going to multiply this just like you would multiply 66 times 6 at first, and then place the decimals afterwards. So 6 times 6 is 36. 6 times 6 is 36, plus 3 is 39. I don't have to multiply the zeros out. All I have to do is count how many digits are behind the decimal in my problem, and that's how many there need to be in my answer. And that's the answer. Let's do 19 the same way. 7 times 9, 63. 7 times 7 is 49. 49 plus 6 is 55. There's 1, 2, 3, 4 digits in my problem, so there has to be 4 in my answer. So it looks like D was your only choice. And the last question, question 20. Be careful when you're subtracting decimals. You need to line up the decimals. And before you subtract, When we borrow, bring our decimal down, and the answer is 3 5/10. I hope this was helpful. Good luck on your test.